Let's solve the problem. Let me divide the screen into 3 regions. You will see why in a second. The first thing that we need to do, since we're going to compute a deadweight loss, is to compute the market equilibrium without a tax or subsidy. In that particular case, the first thing we need to do is we know the aggregate demand, which is just 10,000 minus 125p, but we don't know the aggregate supply. So let's compute it. We have 100 firms with a cost function equals Q squared. Is easy by all of the methods that we have shown to show that their supply function of these firms is given by P over 2. For the other 100 firms with the cost function equals to 2Q squared, you should almost in your head be able to compute that their supply function is equal to P over 4. Adding horizontally, we are going to get that the aggregate supply for the market is equal to 75p. 100 of this plus 100 of that gives us this. Now, what's the market equilibrium? It's going to be given by aggregate demand equals aggregate supply, which implies at equilibrium 10,000 minus 125p equals 75p, and this implies that P star without policy is equal to 50 and Q star is equal to 3750. Okay, so we have the benchmark. Now let's look at the case of a subsidy. Since both policies are on the producer, we know that the demand for the subsidy case is equal to the demand when there is nothing. Now what happens to the producer? We know that for the producer, it's going to respond to the subsidy by shifting its supply down. In this particular case, it's going to be equal to the supply of what it was willing to do plus the amount of the subsidy, that is 40. Why is that? Well, what the producer is very simple to what we saw in the previous practice problem. What the producer cares about is the net or total price that it gets. And since it's getting the 40, is willing to supply at a lower price than before because the 40 kind of makes up the difference. That's why the supply curve shifts down. Now, this implies that in equilibrium, we're going to have that 10,000 minus 125p is equal to 75p plus 40. And if you solve this, this is going to imply that P star with subsidy is equal to 35 and Q star with subsidy is equal to 5,625. Now, to compute the deadweight loss, note the following. If you do the graph of this situation, we have the aggregate supply and the aggregate demand before the policy. Then what happens is that the supply curve is going to shift down by 40, and the quantity demanded, so the quantity produced is going to go up, and the deadweight loss is this triangle. Okay? Now, what is the area of that triangle? It's 1/2 times this distance, which is the distance between the amount in the market equilibrium and this other amount, so 56025 minus 3750, times this height. But that height is exactly the size of the subsidy, so this times 40. And this is basically equal to 1875 times 20. Now let's do the case of the tax. In this case, again, the demand with the tax is equal to the demand without, and the supply with the tax is equal to the supply shifted upwards. So it looks like this. Implies at equilibrium, we're going to have that 10,000 minus 125 is equal to 75 times P minus 40. And if you compute the equilibrium, you get that P star with the tax is equal to 65, and a quantity star with the tax is equal to 1875. Now we're in a situation in which the deadweight loss look like this. You have X demand, X supply. The supply has shifted like this, so quantity has gone down, and the deadweight loss is this. Okay? And it's very easy to compute that in this case the deadweight loss is going to be equal to 1/2, is again the area of a triangle, times the difference between the optimal quantity and the quantity produced, which is again 1875, times the gap, this gap, which is equal exactly to the shift, the amount by which the supply curve has shifted, which is 40. So we get that again is 1875 times 20, and we get that the two deadweight losses are the same. Please don't conclude from this beautiful example that this equivalence is always there. This really depends on the case of linearity, but to the extent that things are locally linear and the introduced subsidy and tax are not too large, this is not a bad insight. They will be approximately the same.